semester. So 5.6 is our last set of notes for the semester. We've been talking about proportions and how similar figures have proportional sides, and we use proportions and cross multiply to find the missing pieces. So what we're looking at today are our similarity statements. These are what you can use to prove that triangles are similar. So if you're not told, hey, these are similar, you can use them to check if they're similar. And then if they are, then you can use proportions and find missing pieces. Okay, so there's 3 of them. These A's all stand for angle and the S's all stand for sides. It's the parts of the triangle. There's either angles or sides. So the angle similarity statement says that if 2 angles, 2 corresponding angles are congruent, then the triangles must be similar. Okay, so when I say 2 corresponding angles, okay, for here in this example, you can see A and D correspond. They're congruent. So 75 and 75. And then you can see C and F are both 31. So that is 2 sets of corresponding angles. So that's angle, angle. So with that information, that is enough for us to say, okay, these are similar triangles. So once we know that they're similar, we need to be able to write the similarity statement. Okay, we talked about this before. So let's just write the similarity statement one more time. So it's going to be triangle, and then we name it, is similar to triangle, and then we name it. Now, when you name the first triangle, we talked about you get to put these letters in whatever order you want. You could go ABC, BAC, CAB, BCA, CBA. It doesn't matter. For the first one, name it whichever order you want. Let's just go alphabetical for these notes. So I'm going to say ABC. Now, the second triangle, the order matters. You have to correspond. So since we started with A, which angle in this triangle is the same as A? D. So I have to start with D. Good. Okay, and then I went B. B is the unmarked angle here, which must correspond to the unmarked angle here. So I've got to go with E next. And then you can see C was the same as F. So those are the corresponding angles. So I have to match that order. Does that make sense? Okay, so let's try one more like that. This one's a little more complex because they're not just drawn side by side in the same orientation. You've got this intersection of lines, okay, and then the endpoints of those segments are connected and it forms these triangles. Now, anytime this happens, I call it a bow tie because it kind of looks, I mean, obviously they're not the same size on both sides, but it's kind of that bow tie shape, right? So when you have the triangles created by a bow tie, if these sides, let me highlight them. If these sides that connect the segments that are intersecting are parallel, these will always be similar triangles. Because we know that in the middle there at the intersection, I know that these 2 angles are congruent because they're vertical angles. Anytime you have an intersection and there's angles across from each other, they're vertical angles. They're congruent to each other. So that's one set of corresponding angles. And then they've gone ahead and marked a second set. They said Y is congruent to V. So is that 2 pairs of corresponding angles that we know are congruent? So that's enough for angle, angle. We have 2 sets of corresponding angles that are congruent. So we can say, yes, these must be similar triangles. So if Y corresponds to V, what does Z correspond to? Yeah, it's got to be the third one over here, the W. So you can mark it or you can just leave them blank as long as they match, as long as you know they correspond. Now, what I was saying about these sides being parallel, instead of telling us they are parallel or marking them parallel, they just labeled the angles as congruent. But I want you to understand, even if Y and V weren't marked congruent, if these sides had parallel markings on them, or you were told they were parallel, you know that those are congruent. Because remember back, I think it was unit 3, where we did parallel lines and the transversal. So if I connect these parallel lines with this transversal, see how it connects this, it makes this zigzag, this V shape. Whenever you have that zigzag shape and you know that those outside ones are parallel, the corners are the same. So it would work as well if I connected it here and did this zigzag. See how those corners correspond? They're the same. Okay, that's always going to be true in these bow tie situations if these outer sides are parallel. So whether they're marked congruent or you're told that these are parallel, you're going to have similar triangles in this situation. So now we just need to name them. So again, the triangle that I named first can go in any order that I want. So the triangle on the left, how do we want to name this? WVX. Okay, so I started with W. So on this triangle, which one corresponds to W? It's W. Yeah, look at the markings we put. The W corresponds to the Z. So I have to start with Z. Okay, and then V corresponds to the Y, and then X corresponds to X. So notice X is a vertex in both triangles. They share that point X. Feel okay about that one? The most confusing thing on the bow tie type questions that y'all are going to mess up on at some point. I mean, I doubt anybody's ever going to get every question perfect as you practice this as we're learning it. But a lot of people mix up and they want to correspond to like the W to the Y and the V to the Z. Okay, so they want to say that this side corresponds to this side, and it doesn't. Okay, it's opposite sides of the triangle. Okay, so just be careful with that when you've got the bow tie. All right, so that's angle-angle similarity. One of the other similarity statements that can prove the triangle's similar is side, side, side. If you know all the corresponding sides, so 3 sets, because we're dealing with triangles. So if all 3 sets of corresponding sides are proportional, not congruent, all sides are proportional. Over here, it was 2 sets of angles are congruent. So angles are congruent, sides are proportional. And it's what we've defined in similar figures. So if all 3 sets of sides have the same ratio, the same scale factor, they're proportional, however you prefer to think of that, any of those ways I just said it, that means that the triangles are similar. So we have to check the ratios and see, are they proportional? So I'm going to make sure that I get the right sides, the correct sides corresponding. So if all 3 sides are labeled, you know which is the longest, shortest, and middle, right? Based on the numbers. So what's the longest side in the little triangle? Yeah, and what's the longest side in the big triangle? 10. Okay, so those have to correspond. What's the smallest side in the left triangle? 3 is less than 4, so 3 is the smallest, and then here 6 is the smallest, and then that leaves 4 and 8 in the middle. So once you know which ones are supposed to correspond, we're going to check the ratios. So you have to be consistent, left to right, left to right, left to right, or vice versa. You get to pick, but you have to be consistent. So if I go left to right, I would do 3 is to 6, 4 is to 8, and 5 is to 10. Those are all the ratios. Do y'all agree? So we are asking, are these equal? It's a question. So I come to my calculator and I type each of those in. What was it? 3 over 6. 4 over 8. 5 over 10. Are they all the same?
Yeah.
Yeah, they're all 1/2. Now, some of you probably noticed that before doing it in the calculator, and that's great. You don't, if you can do it in your head, fantastic. If you can't, use Desmos. Okay, all of these reduce to 1/2. This triangle is half. Each side is half the length of the large triangle. So that's proportional because they're all the same ratio. So this one would be yes, they're similar. And so then I would write my similarity statement and I would name them and I would pick any order I want for the first triangle. How do y'all want to name this one on the left? QPR. And then I have to match that. So what angle, no, and you can add the angle markings in the picture if it's helpful to you. We have the highlighted sides, but if you want to mark the angles, see Q connects blue and green. Blue and green is T. So I've got to start with T. Okay, and then I went to P. P connects blue and yellow. So blue and yellow over here is F. And then that leaves R to U. Does that make sense? So I checked the ratio of all 3 corresponding sides. They were all similar. So yes, these are similar triangles. Okay, so let's check this last one. Now this one, it appears that it's drawn in the same orientation, but you always still want to double check that it's long to long, short to short, medium to medium. So over here, 30 is the shortest, and over here, 24 is the shortest. Okay, 35 is the longest, 28 is the longest. Okay, so we can see which ones correspond and set up those ratios and we'll check them. So we're going to check 30 is to 24. 35 is to 28. And 32 is to 25. So this one's not as obvious. Oops. This one is not as obvious as the 1/2. All those reduce to 1/2. You may not be as easily able to reduce sometimes. So sometimes you may rely on your calculator. Yes. So 30 over 24, 35 over 28, 32 over 25. Did those all come out the same? Oh, they didn't this time. Let's double check. 30 over 24, 35 over 28, and 32 over 25. 2 of them came out the same, but the third one didn't. That's why it's really important that you check all 3. If you only checked the first 2, you would have thought, oh yeah, they're similar, and given the wrong answer. And you can look at them as fractions if you want. That one does not reduce to 5/4 like the others. So my answer here, when I check those, it's a big, I'm going to put a slash here. That last one is not equal. So these are not similar triangles. So I don't write a similarity statement because they're not similar. Does that make sense? So sometimes you're going to check and they're not similar. Good? All right, last but not least, the last similarity statement that proves the triangles are similar is side angle side. Now, that's 2 sets of sides have to be proportional, okay? So 2 sets of sides are proportional. Now, it's really important that we understand this terminology here. It says the included angles. See how the A is in the middle of the 2 S's? It has to be in the middle of the 2 sides that are proportional. And if that included angle is congruent, then the triangles must be proportional. Okay, but it's got to be the included angle. Okay, so here in this image for number 5, the 2 sets of sides that are labeled would be 8 And would you think the 8 would correspond to the 6 or the 15? 8 less than 20. So should I correspond it to the 6 or the 15?
6.
The 6. Okay. And then the 20 would correspond here. So the included angle is K and N, right? And that's already marked congruent. That's what that little arc means. So we've got the included angle is congruent. So we've met that part of it. Now we just need to check the proportion of these two sides and make sure they actually are proportional. So I'm going to say 8 is to 6 as 20 is to 15. And when I go to check that, 8 is to 6, 20 is to 15. I see they are proportional, right? So yes, the two sides are proportional and we have the included angle. So these triangles are similar. So now I can write my similarity statement. So the triangle on the left, I'm just going to name it JKL. So notice I went from J to K. So I went along the green side and then the pink. So I have to do the same thing, go along the green and then the pink. So that's MNP. Now, when we have the nested triangles, one inside the other, if it's helpful to you to draw them side by side, you can. I know I showed you how to do that in some of our other notes. So if you want to take those triangles, take the small one and then the big one and have them side by side, if that's easier for you, do that. So the small triangle is ADE, and then the big triangle is ABC. So obviously when you have a nested triangle, A is in both. Do you see that? So A is congruent to itself. It has to be. It's the same angle. Y'all agree? So we've got an angle congruent. Now we have to check if we have the proportional sides. So in the small triangle, this is 15 and 12. And in the large triangle, they say this is 25 and 21. Now, sometimes if they gave you, instead of giving you the entire side length like this, if they gave you that little piece, what would you have to do to get the entire side length? What if they told you this is 15 and this is 10, but they didn't tell you the total was 25? Where's the 25 coming from?
Together?
Yeah, you'd have to add the two pieces together to get that big side length. Okay, so sometimes they'll give you the big side length. Sometimes they'll just give you this little piece and you've got to do the addition. Okay, so just be careful. So now I'm going to set up my proportion and I'm going to check. Okay, so the corresponding sides here, if you need to color code them, go ahead and color code them. Okay, that would be the AD to the AB and the AE to the AC. So when I set up my ratios to check, it would be 15 to 25 and 12 to 21. That's what I'm checking. So in my calculator, I type in 15 to 25 and 12 to 21. Are they the same? No, 3/5 and 4/7. So those are not proportional. Okay, so those are not equal. So they are not similar triangles. So that's why it's really important you check. Don't just assume that the triangles drawn are similar. They might not be. Okay, so these were not, even though these had the angle congruent, one of the angles was congruent, but those sides are not proportional, so these other angles must not be congruent. They might be really close, but they're not the same. Okay, they are not similar triangles. Okay, now, if you want to add this up here, because the most common thing people get confused on is the included angle, okay? It cannot be any random angle in there. You cannot have side, side, and then one of the other angles. It has to be the middle angle, okay? And the easiest way for me to help you remember that is to put angle side, side, and spell a bad word. Ha 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 ha. It's a bad word, so it's bad. Don't use it. It does not prove similarity. It has to be the angle in the middle of the two sides. Does that make sense? Okay. So y'all are going to practice this in a Delta Math on 5.6. It's linked in Canvas. If you are behind, if you haven't finished ones from earlier in the unit, you can finish those first. I highly recommend that you check 5.3 is complete because it's due today. So if you haven't finished 5.3, get it done first and then move on to the next one. 5.4 and 5.5 are due this weekend, and then 5.6 is due by Tuesday. Okay. We have our quiz tomorrow. So the more practice you can do, maybe you want to mix it up, do a little from each section instead of doing all one at a time. That way you might be a little better reviewed and prepared for your quiz.
Wait, can we use our notes?